Welcome back to our lecture series of complex analysis. In this lecture, we will study the complex logarithmic function. In the previous lecture, we discussed the complex exponential function, and the moment we have the concept of complex exponential function, then we are able to discuss the logarithmic function in the complex analysis. Okay. हमने लास्ट लेक्चर में ये देखा था दैट e टू द पावर z इज नॉट 1 to 1 1 to 1 when the domain is the whole complex number system. ओके फिर हमने इसको वन वन फंक्शन बनाने के लिए वी डिसाइडेड अ फंडामेंटल रीजन जहां पर y वाज वेरिंग फ्रॉम माइनस पाई टू पाई एंड x वाज वेरिंग फ्रॉम माइनस इन्फिनिटी टू प्लस इन्फिनिटी. नाउ क्योंकि ये e टू द पावर z वन वन नहीं है तो इसके कई सारे कॉन्सिक्वेंसेस भी होंगे. उनमें से एक क्या है दैट the equation or more precisely you can say this is implying okay that e to the power z is not 1 1. उसका ही एक consequence हमें क्या मिलता है that the equation e to the power w is equal to z has infinitely, or you can say infinite solutions. Okay, for example, if I say e to the power w equals to iota, then we may have w equals to pi by 2 iota, then we may have 5 pi by 2, then we have minus 3 pi by 2, and like this. Okay, so these kind of values for w will be solution of this equation. अब इस तरीके की इनफाइनाइट सॉल्यूशन हमें क्यों मिल रहे हैं? जब हम इस क्वेश्चन के आंसर के बारे में डिस्कशन करेंगे तो उसी डिस्कशन से वी विल हैव द कॉम्प्लेक्स लॉगरिथमिक फंक्शन. सो लेट मी राइट द क्वेश्चन फर्स्ट. सो वी हैव दैट वी वांट टू नो दैट व्हाई द इक्वेशन e to the power w is equal to z has infinitely many solutions. We want to see this. Okay, now suppose if you want to choose this w as u plus iota v, then we need to identify u and v. Okay, so let us have this discussion. So suppose that we have e to the power w equals to z where this w is equals to u plus iota v. This u is the real part of this w and v is the imaginary part of w. हमें इस w को ही आइडेंटिफाई करना है. एक्चुअली ये जो इक्वेशन है वो w के लिए ही सॉल्व होना है. ठीक है, and where this w is like this and z is any non-zero complex number. Any non-zero complex number. ठीक है, now you can see why we are taking this z is a non-zero complex number. क्योंकि हमने previous lecture में prove किया था that 0 is not in the range of e to the power z. That is w की ऐसी कोई भी वैल्यू हमें नहीं मिलेगी जिसके लिए e to the power w हमें 0 मिलेगा. That means this z is never equal to 0. That's why we are saying that z is any non-zero complex number. Now from the polar form we can say or the exponential form we can say that z can have this form. Okay, so we can suppose the exponential form of z as, let me call this as equation number 1, this is equation number 2, this w को ही हमें आइडेंटिफाई करना है. ओके, and we are writing this as z is equals to r e to the power iota, and this is capital theta. Okay, where we have that this theta is running from minus pi exclusion to pi inclusion. Okay, so let us call this as a question number 3. Now the moment we are taking this theta is minus pi to pi, that is this capital theta is the principal argument for this complex number, non-zero complex number z. Okay, now the moment we have this representation for z and this representation for w, then for this value, if we plug in 2 and 3 into 1, then we can write as, then using 2 and 3 into 1, we have that e to the power u plus iota v is equal to r e to the power iota uppercase theta. Okay, and this equation can be written as e to the power u e to the power iota v, that is equals to r e to the power iota uppercase theta, right? Now if you compare these two equations, then you can write that this implies that e to the power u is equal to r, and we have that this v is equal to some theta plus 2 n pi, right? And this where this n could be equals to 0 plus minus 1 plus minus 2 and so on. Okay, this can be anything from these integers. Now the moment we have the value of e to the power u and v, then we are now able to write the value of the complex number w. Look at this. This v is real number. This r is real number. So you can say this particular equation represent the exponential function in the real number system. And the moment we have the real number system, we can write this as in form of real logarithmic function. Okay. Here, since u and r both are in real number system, so e to the power u represents the real exponential function, and for the real exponential function we know the real logarithmic function provide the inverse function, right? So real exponential function, so you can say e to the power u equals to r, that implies that this u is equals to ln r, where this ln represent the, where this ln is real logarithmic function. Okay, so we have the value of u and the value of v, and the moment we have the value of u, suppose we are calling this as equation number 4 and this is as equation number 5. Now then, using 4 and 5 into 2, that was the w, we have the value of w as w is equals to, u was the real part and that is in the form of ln r plus then v iota time this uppercase theta plus 2n pi, right? Where you can specify that n can be equals to 0 plus minus 1 plus minus 2 comma and so on, right? So this is the value of w when we are given e to the power w is equals to r. So we have this solution. Now you can see If we write n is equal to 0, then we have one solution. If we write n equals to plus 1, then we have another solution. So this is how we have infinite number of solution. And hence, let me write, and hence for each value of n, w represents a solution to e to the power w is equals to z, and thus there are infinite solutions to the equation e to the power w is equals to z. Okay, so due to the values, various values of n, we have infinite number of values of this w. Okay, and the each w will decide a solution for e to the power w equals to z. That's why we have the infinite number of solution. Now from this equation, if we represent, say, मैंने कहा था कि जब हम इस सॉल्यूशन के बारे में बात करेंगे, देन समवेयर वी विल हैव द डिस्कशन ऑफ लॉगरिथमिक फंक्शन. सो नाउ फ्रॉम पर्टिकुलर दिस इक्वेशन, so suppose now if we write, okay, the please pay attention to this word if. Okay, so if this word is very important, okay, if we write that log z is equals to ln r plus eta uppercase theta plus 2n pi. If we suppose this, okay, where this n is equals to 0 plus minus 1 plus minus 2, we are supposing, we are not defining, we are supposing this. Okay, then अगर हम इसको यूज करें, लेट मी राइट दिस इज इक्वेशन नंबर 6. तो अगर हम w की वैल्यू को log z पुट करें, देन with the use of 6, equation 1 can be written as look at the मोमेंट ऑफ डिस्कशन. हम किस तरीके से किसी नए कंसेप्ट को कॉम्प्लेक्स एनालिसिस में इंट्रोड्यूस कर रहे हैं. ठीक है, one can be written as, the equation 1 was e to the power w. Now in place of w we want to identify log z, okay, as e to the power log z is equals to z. Now look at this, अगर हम e टू दी पावर log z इक्वल्स टू z लिख रहे हैं, तो क्या हम ऐसे नहीं कह रहे कि इस कॉम्प्लेक्स एक्सपोनेंशियल फंक्शन e के लिए वॉट एवर दी फंक्शन इज इट, मैं ऐसे अभी तक कॉम्प्लेक्स लॉगरिथमिक फंक्शन कॉल नहीं कर रहा हूं. जो भी ये फंक्शन है दैट प्रोवाइड एन इनवर्स फंक्शन. ओके, अब ये क्योंकि एक्सपोनेंशियल फंक्शन का इनवर्स रियल एनालिसिस में लॉगरिथमिक फंक्शन है, तो हमारे लिए एक इंट्यूशन है कि क्या ये फंक्शन भी कॉम्प्लेक्स लॉगरिथमिक फंक्शन के जैसे हम डिफाइन कर सकते हैं क्या. सो दिस इज द एक्चुअल मोटिवेशन टू कॉल दिस फंक्शन एज कॉम्प्लेक्स लॉगरिथमिक फंक्शन. ओके, अब ये क्यों है, लेट मी टेल यू दैट ऑल्सो. एंड दिस इज वेन z इज नॉट इक्वल टू जीरो, राइट. ये हमेशा हमें याद रखना है कि क्योंकि इट एक्सपोनेंशियल फंक्शन कभी भी जीरो नहीं है, एंड वॉट एवर द कॉम्प्लेक्स फंक्शन z इज इट इज इक्वल टू द एक्सपोनेंशियल फंक्शन, और ये कभी जीरो नहीं है. दैट्स वाई दिस z इज नॉट इक्वल टू जीरो. ठीक है, नाउ लेट दिस z is equal to x, and that is of course is strictly greater than 0. And so let me call this as equation number 7. Okay, then from 7 we have that e to the power log x, that is equal to x. Now look at this, when x is real, then we have the same scenario as we had for the real exponential and real logarithmic function, right? तो अगर ये जो भी हमारा रिजल्ट है, जो भी रिलेशन है, जब हम उसको रियल पर बात कर रहे हैं, तो ये रियल लॉगरिथमिक फंक्शन जैसा बिहेव कर रहा है. सो नाउ दिस particular discussion suggests us that this log z is nothing but the complex logarithmic function. Okay.